So in this video, now that we've looked at all of the conic sections, we're going to look at how to complete the square to get them into standard form and to identify which conic section we've been given. First, I want to make sure that we can quickly identify which shape we have, even if it's not in standard form yet. So one of the things I like to look at is whether there is both an x squared and a y squared term. If we only have an x squared or a y squared, but not both, then I know right off of the bat that it's going to be a parabola. The next two cases are a little more similar because they both have x squared and y squared in them. The difference between the ellipses and the hyperbolas is whether the terms for the x squared and y squared have the same sign, so they're both positive or they're both negative, or if they have different signs. So one of them is positive and one of them is negative. Now make sure when you're comparing this that you have all of the terms on the same side of the equation first, because if they are on opposite sides of the equation, they may end up having their signs flip when you're moving them from the right side to the left side and vice versa. So that may affect whether you're thinking they have the same sign or the different sign. So put them on the same sides of the equation and then check if they have different signs or the same signs. Circles are a type of ellipse, so they're something that we've already looked at for this process, but basically it's the same situation where we have an x squared and a y squared. Those two terms do have the same signs, and more specifically, they have the exact same coefficients. So it's like a 4x squared and a 4y squared. So that's the first thing I like to do. And then once I know which shape I have, then I can start following the process that I have here. So I like to group all of the x and the y terms together. Now you'll know how to group them according to the standard forms for each of the shapes. For example, if it was the parabola, we said there's either an x squared or a y squared. So those terms would go on the left-hand side. Everything else would go on the right-hand side. For the ellipses, I know that I'm going to have the x's and the y's all on the left-hand side of the equation, and it's the same situation for the hyperbolas. The big difference between the ellipse and the hyperbola, it's whether I'm going to have a plus between the fractions or a minus between the fractions at the end. So first, group the x's and the y's on which side of the equation you need them on. Next, I look for any coefficients on the x squareds and y squareds, because you can't complete the square if there's a number attached to that x squared or y squared on those terms. It doesn't matter on the other variables, the x to the first power and y to the first power. But on the x squared and y squared, there cannot be a coefficient before we complete the square. So we would factor that out if there is one. Next, we will complete the square on the x and the y terms. That's where we take half of the b value, the number in the middle of a trinomial. So we take half of that number and we square it and we add it to both sides of the equation. Now there is a complication that combines with our factoring step from the previous line, so I will demonstrate that if it occurs. And then the last step changes a little bit for the parabolas and the ellipses hyperbolas. So you want to make sure you know which shape it is before you get to this point. For parabolas, you will factor out the GCF on the right-hand side of the equation because I'm expecting it to be a number out front times y minus something or a number out front times x minus something. So there's a GCF factoring that creates the 4p piece. For the other values, for the ellipses and the hyperbolas, once we get the x squared and the y squared stuff all completed, the square, all that stuff done, on the right-hand side of the equation, we should have a number like 36 or 42. Whatever that number is, your last step is going to be to divide everything in the equation by that number and then reduce the fractions if possible. Because the idea is that the right side of the equation should always be a 1. We should not have any other numbers over there, so whatever number you have, divide everything by it. So let's look at a couple examples. First thing I want to check is which shape do I have. So I look through all of the terms that I was given. I see an x squared, but I do not see a y squared anywhere in the equation. So to recap on that, this has to be a parabola because it has an x squared or a y squared, but not both. So now I know that I'm going to be looking to have only the squared variable on the left-hand side, and everything else I'm going to move to the right-hand side of the equation. So in this case, I'm going to leave my x's on the left. Remember, I'm going to leave a blank space for when I complete the square in a moment. And I'm going to move everything that doesn't have an x in it to the right-hand side of the equation. So I'm subtracting 4y from both sides, and I'm adding 7 to both sides. So now that I've set up the terms and grouped them accordingly on the right sides of the equation, I'm going to complete the square. So I'm going to use a different color to indicate that I'm taking half of this middle number, which is 1, and then I'm squaring it. We add that number to both sides of the equation. So that's the completing the square step. I did not have a number on my x squared to factor out, so I didn't have to worry about any of the complications yet. That'll come up on a later example. So factoring the trinomial, we need to find two numbers that multiply to 1 and add up to 2, but as a good shortcut, whenever you complete the square, your factoring will be half of the middle number, half of that b value, squared. On the other side of the equation, I can combine the 7 plus 1 to get 8. So now we've completed the square. Going back to my steps here, I didn't have to do the second step. We completed the square. Now for parabolas, I just need to factor out the GCF on the right-hand side of the equation. So coming back to my example, basically I don't want a number attached to the y in this case. So what I'm going to do is factor out that number from everything. So I'm going to take -4 out of both of these terms. That leaves me with y minus 2. So that's my standard form of a parabola. Next example. Again, I want to start off by identifying which shape I have before I start rearranging the equation and grouping the terms together. This time I do see an x squared and a y squared, so I know I want them on the same side. More specifically, since I told you that they have the same sign, they were both positive, then that means I know I actually have an ellipse going into this. But it's enough for me to know right now that everything's going to stay on the left except for the constant. We're going to move that to the opposite side. So my first step is let's group together the x's. I'm going to leave a blank space for completing the square. Then I'm going to group together the y's. And then I'm going to move the 5 to the opposite side of the equation. So now I have equals 5. On my x squared, I do not have a coefficient. So I can go into completing the square on this. I take half of the middle number, which is 2, and I square it. So that's going to be +4 to both sides of the equation. Now, since the y squared term did not have a y to the first power, I don't actually have to complete the square on that. There's nothing to take half of. If you want, you can think of it as 0y. So half of 0 is still 0, squared is still 0. Nothing's getting added to both sides of the equation. So basically, if you don't have an x or a y to the first power, you do not have to worry about completing the square at all on those. Next, I factor this again. So the completing the square set up a trinomial. It will be x plus half the middle number, which is 2. And then for the other number, I didn't have to complete the square, so that's just going to stay as 3y squared. On the right-hand side of the equation, 5 plus 4 is 9. So now let's look back at our next step. Since we said this one's going to be an ellipse or a hyperbola, now I need to divide everything in the equation by the constant on the right-hand side. So going back to my example, the constant I have is 9. So I'm going to divide everything by 9. And then we need to reduce these fractions. There's nothing to reduce on the first one. So my answer here is going to be x plus 2 squared over 9. On this next fraction, the 3 over 9 can be reduced. So if I reduce that part of the fraction, I'm left with y squared over 3. And then on the last part, this should always come down to a 1. If it's not a 1, then something's gone wrong in your work, because a number divided by itself should always equal 1. So that's my standard form for the ellipse. I have a fraction plus the fraction equal to 1. I could find the center, the a values, the b values, and everything else for the ellipse. My last example. It's going to be fairly similar to the last one because the ellipse and hyperbola have a lot in common, but I did add some of the complications to this one. So this will be the toughest of the examples so far. First, I like to look through the equation. I see an x squared and a y squared. That's how I know that this is not a parabola. I also see that the x squared term is positive, but the y squared term is a negative. So as far as identifying the shape, I do have an x squared and a y squared, but they do have different signs. So that's what's making this one a hyperbola. So if I wanted just to remind myself the general form of what I expect for my final answer, it should be one of these two situations. So I know I want a hyperbola. That means I want to group together the x's on the left-hand side. And then I have a minus 12x. So I'm rearranging this a little bit to put the x's next to each other. Now I'm going to group together the y's. Again, I'm leaving a blank space for completing the square here. I have a minus 24y. Leave another blank space for completing the square on the y's. And then the constant, I want to move that to the opposite side. So that's going to equal negative 60. Now if I go back to the steps we've been following here, so this time I grouped together the x's and the y's, but now I do have a coefficient on the x squared and the y squared actually. I have a coefficient on both of them. So what I need to do is factor that out of the x's and the y's on this example. So my next step, I see that there's a 2 on the x squared. I can't complete the square if there's a 2 attached to it. So what I need to do is take 2 out, which will make this x squared minus 6x. Same thing is happening for the y's. I do have a number on the y squared. And this time I have to complete the square with it because I do have a y to the first power. So I need to factor out this number that's attached to the y squared. So I'm going to take negative 3 out, which will leave me with y squared plus 8y. So this is going to affect our completing the square step in just a moment. But to recap, the idea here was I can't complete the square if there's a number on the x squared, so factor it out. Now I can complete the square just on what's inside of the parentheses. I'm just going to be focusing on that part for completing the squares for a moment. So going back to my rules, Now let's complete the squares and see what happens on both x and y. So I'm going to take half of the middle number, which is -3, and then I'm going to square it, which is +9. But here's the trick that occurs when you have to factor something out of completing the square. I didn't actually just add 9 to the left side of the equation. Because of the distributive property, I actually added 2 times 9. So because I factored that 2 out, I need to add 2 times 9 to the right-hand side of the equation, or my equation wouldn't be balanced anymore. Now the same thing's going to happen with the y's. If I'm just looking at the stuff inside parentheses, half of 8 is 4, squared is 16. But I didn't actually add 16 to this side of the equation. Because of the -3 I factored out, if I distributed that, that would actually be -3 times 16, which is -48. So I need to make sure I'm including what I factored out, because that does affect my completing the square and what I added to the left side of the equation. Okay, so that's the biggest trick there. The rest of this follows about the way I expected. So now I can factor this down. It's always going to be half the middle number squared. So half the middle number was 4 squared. And then you may want to calculate these out. So 2 times 9 would have been 18, and that was a +18. And then this would have been a -48. So basically I had -60 +18 -48. So let me, instead of writing -60, let's just go ahead and combine those together right now. So then that would be -90. So don't forget to distribute and then just combine those like terms. -60 +18 -48 gives me -90. One last step. Our last step, now that we've done the difference of squares, after completing the square, we need to divide everything in the equation by the constant on the right-hand side. So the constant that I have right now is -90. I'm going to divide everything by -90 and then reduce those fractions. So the 2 and the 90 will reduce, and also this does flip the sign on my fraction. So now it's going to be x minus 3 squared over 45. This was negative, but I'm dividing by a negative, so now it's going to be a plus between these fractions. So I would have y plus 4 squared over, and the 3 and the 90 reduce, so this one's over 30, and then this would equal 1. Now one last thing to point out on this, since I was dividing by a negative number, that flipped the signs on my hyperbola fractions here. So if I look back, remember we want the positive fraction, and then we want to subtract the second fraction. Well, right now my order's flipped because I divided by a negative number. So the last step I would do on this is I would change the order of these. Let me see if I have enough space to write this just below. So I would flip the order and write it as y plus 4 squared over 30 minus x minus 3 squared over 45 equals 1. That would be my final answer for the standard form on the hyperbola. And that's it for identifying the conics and for putting them into the standard form. Again, the hardest step is making sure you remember to factor out the numbers on the x squared and the y squared if you have a coefficient, and then making sure you remember that that affects what you're adding to the right-hand side of the equation. So just multiply whatever you factored out by the completing the square term. That's it. Thank you.